the index, then find the data directly. So which is very convenient and efficient to access the data. So that is some point, and each operating system provides a different. For example, the VMS is a fax machine. I don't think that you have seen the VMS, but if you go to the market, some of the retail, the shop, the register has something. It's not like the graphical user interface, but it's like the menu. Even they can type using the tab, moving the menu. So interface. It's in between the command line interface and graphical user interface. So that was actually the started from the VAX, the operating system. VAX has the VAX system has a VMS operating system. They have their own index, the structure. Basically, their idea is the index is separated from this one. Depending on how to organize the index, it will be the different types of the index. Okay, so access method, the sequential, and also the random access using the pointer, then or address. Then in addition to that, there is an index-based access method using the index. You can speed up. These are the overview overall of the file structure. Then the problem is, so each file we can create, we can manage the number of applications, we can access the data, we can do whatever we want. The problem is when we find the data from a specific file, we need to decide which file we are going to access. So when you have the 10 files, so I think the one of the project scope in the second part of the first project is you can list up the executable file from the local directory, then the select, by selecting you are able to create a new process or execution. At that time, you should be able to search the executable file from your local directory or current directory. What if you have the millions of files in your operating system? Maybe possible your operating system has at least 200, 300,000 files if you check your antivirus program, so easily. So even it takes a long time to search the specific file. So we do better to address such issues. So idea is simple. Why don't we group the file? They are the similar file will be grouped. Like nowadays group by what? The first, when we create the user, what happened in any operating system? What happened when you create a user? Memory? Allocate the memory. Before you use such a memory resource, most of the time, think about the kind of its pattern. In operating system, when you create a file, what happened? You are using system library to create a file, and output is the identifier, process ID. And when you create a file, the file descriptor is the identifier. When you create a user ID will be created. You should have the user ID. So when you create a user, there are different commands to create a user. Even though you do not know how to create a user, actually, if you assign the user ID, it is possible. It was possible. For example, if you go to when security was not the critical issue, so you can directly go to this is the root etc/password file. You can edit password file, then still there exists. If you go to the compute engine, okay, or the virtual machine, any operating system, Linux or Unix-based operating system, go to here and open this file. Then you can see number of users. You can actually add a new user by adding the ID, user ID, and group ID, username, editing. That means you create a new user. So ID will be assigned and added to but nowadays you cannot directly edit. Although you edit, it will not be applied to the older system. Then, after you create a user, which means assign the user ID, then you should have something file system, location, your house, your home. So home directory will be assigned. then at the home, then your username. User ID will be assigned then the JELEE. So more important thing is this one, but for our convenience, we are using username. So using the same username, this will be, depending on operating system, may be different. Windows is the same thing. So this file, this directory means all the files that I'm going to create here will be under JELE. It's a group by user. And the etc, the files grouped by the etc. And temporary is a group by temporary. So for depending on the objective, it can be grouped by something. So group means group of the file. So we need a new data structure to manage it. It's not file structure. It's not the structure to keep the data, but to manage the number of files, we need a new data structure that is the directory structure. When I learned the computer first time, 1982, I think that was the first time to learn through the MS-DOS. So I learned the DOS command. DOS is the also operating system, as we discussed. It's a single job operating system, which means so I learned command like the cd, change it directory, create the directory, okay? Because main part of the such operating system, one of the main part is the file system. And the file system, two main, the data structure, file and directory. So many of the commands of the such MS-DOS are related to file and the directory. So directory will be used to manage a number of files. So by the way, what is a directory? It's a folder. So what is a folder? It's a directory. Data structure. What kind of a data structure? Is it the same as a file? File has the header plus data mostly, attribute and operation and data. But the directory may have the same thing. No, it's a slightly different. It has the information about the file. Okay, it doesn't have the real data. Instead, as we discussed, the file has the header attribute plus the data. But problem is when we have a huge number of files, it will be hard to find where's the a.txt file. Instead, why don't we take out this part? Header information. Okay, metadata. Sometimes it's called the metadata or header information, attribute information from each file. Okay, then manage only the file information. For example, I'd like to search the a.txt file. Instead of accessing all the file header, we are going to access only this header information that is the main objective of the directory. So directory is also data structure, which means you can implement. So think about it. If you implement, I'd like to make the new file system. So I need the directory structure. How can you implement the directory structure? Using Java, for example. We need to define a number of class, right? So what will be the basic unit of your management? Basic unit will be header. These are the data for directory. Okay, you have a number of header information, which means we are going to manage for example, file name, the ID, file descriptor, and the size. Such a information attribute will be managed by it's called the file control block. So we are going to design the file control. This is the first job of your project, second project. You should have your own file control block, like the what? PCB. When you are doing when you manage the number of process. So how can you manage the number of process, like in the scheduler or the other thing? You don't have to access all the process information. Instead, PCB. using the PCB, we can schedule, we can do something. So similarly, when we manage the number of file, instead of all the information, you define, I need this information, then define the FCB data structure. In case if you are developing the Java-based operating system, this will be the one class. Okay? So I need the FCB class with this. That method, we are going to access this information or update or to do something, search the specific file. So this is the FCB. So directory has the FCB file control block for each file. Okay. So your first job of the second project is to design your own FCB. Definitely, I'd like to see whether you. Sometimes some of the students do not use the separate the file structure. That doesn't mean you don't use. You use such information as for example, file the array. You define string separately. Then it will be hard to manage. Instead, if you define this one, it will be one data structure. It can be accessed by the other part of operating system also. Okay, so this is the directory structure that we are going to discuss here. So we already see such a disk structure. So the directory will. I don't have so we already discussed about this one before. So this is a typical organization of the file system. So let's say we have the one disk, or so in this case one disk. So we can divide the one physical disk. Okay, hard disk drive, for example, into the number of partition, like the C, D, the E, F, such a partition, or in the Unix you can divide the number of partitions. Then each partition has a number of files, and those files will be managed by the directory using what? The file system. Okay. So this is our goal, to use the directory structure as a part. But sometimes you can create a partition with a number of disks, but logically it's the same thing. So in this case we have the one file system, in this case the two file system. It's not different from the operating system point of view. Okay, then such a file system, we will discuss more, but such a file system has the variety of them. So what kind of file system you are using on your operating system? NTFS, if you are using the Windows. If you are using the old version of Windows still, FAT32, I don't think you are using FAT16. So, but we will see what is FAT, the file system before. If we are using the Windows or the Linux or the Unix system, it has the Unix file system, GFS or EX, something number. There are a variety of them. So these are the file system, general purpose file system. It's a general purpose. However, if you take a look at the operating system, actually there are many others. It's not only just a single file system. It can be this one is NTFS, this one will be the FAT, and also this one will be something other file system, because you do not use only the Microsoft Word for editing. You can use the Notepad, you can use the Notepad Plus, Ultra Editor, or many other editors. Similarly, for the file management file system, you can use many file systems. Some of them are specific purpose. Even though you do not realize you are using such a file system, there exists. Like for example, temporary file system. This one is the memory based. For example, as I said, when the file system started, some of the information will be loaded into the memory, and part of the memory is the part of the file system. That is a temporary file system, TMPFS. And some of the file system has only the object file that can be managed by the main operating system and so on. Okay? So these UFS, DFS are the general purpose of file system. We will see more details in the next chapter, such a file system. Okay? Then the directory. So just like the file, we learned about the attribute and operation. So what kind of the operation you can do in the directory? So you can create the file, delete the file, list the file, rename the file, and search the file. So these are the operations, which means if you implement your file system, then you need to design the directory structure class, then this will be operation that you are going to implement. Okay, then what is the main purpose of the directory structure? To manage the number of files, huge number of files efficiently. So depending on how to manage such a number of files. When I'm saying the managing the file, that means manage the FCB of the such a file, each file. You don't have to access each and every file, instead the FCB. So file control block. Okay, so before we start discuss about the directory structure, data structure, so main purpose of the directory is to manage the number of files. So first we define what is the problem when we have the many files. Okay, the problem is, for example, if you are using single directory, no directory, which means file system manages all the files together. First, name should be different, right? If you have the same name, it will be fine in terms of the ID, identifier, but for the application, for your convenience, it's very complicated. It's a naming. So first thing is a naming problem. So we need to, even though the operating system uses ID instead of the name itself, but still it's confused. So naming problem is one issue. So another problem is that because each and every old file in the same location, the file system, definitely it is very hard to manage. Like the executable file, object file, source file, and data file are all together, it will be harder. So that is called the grouping. So there exists two problems. One is the naming and the grouping. The directory structure would like to address such an issue. So first, the one is, as you can imagine, just a single level directory, which means we create a directory for the group, like a cat, pool, or task, whatever. The grouping. Okay? So single level is simple. Still exists. It's a reasonably address the problem of the grouping and the naming, but it's not always. So for example, the naming problem. So in one directory, it's still the same. It may be the same name, and also, what if the grouping? So let's say the data is this is a username, cat or A. So each user may have the data file. So data file here, data file here, data file here. It's scattered by the user. There's no way to share such the data because it's grouped by only one category. Grouped by user, grouped by the data, a type, grouped by something. It's only one criteria for the group. It still exists a grouping problem. So to address, so we can consider such the multi-level, the directory, two-level directory structure. So we can consider not only just one criteria for the grouping, we can consider two, like the user. This one is user, this one is a file type. Okay, then finally we can have the file. So to access the file, we need to start from this user one, and cat finally, this one represents the number of file. Okay, circle doesn't mean one file, number of file. So we can specify the name. So that means user one and the cat and the file name. Okay, so this is called the task. Okay, so that is the reason. So when you start to learn the operating system, like the shell programming, you start from the single. This is a special directory. So single dot is the current, double dot is the pattern, because you should be familiar with the path of the file to access, to learn, to open, to manipulate such a file. So this is a multi-level, the two-level directory. So we can solve reasonably the problem of the naming And grouping is still issue. So for example, the test is all user has a test. So if you want to access all the test file, you need to go to the user 1, access this file. User 2, access this file, and so on. So this is the still issue to use in the Backtracking. So we can generalize into the tree structure like this one. This is what we are using. Mostly it's similar. It's a tree structure. So at that time we call the top level the grouping directory. This is a directory. Directory is a multi-level directory. So eventually it formed the tree structure. The reason why we call the tree structure, what is the difference? We will see the something graph directory structure later. Okay? It will be better to understand the difference between the tree and the graph. Yes?
Could you explain again about like the 1 dot and the 2 dots?
It's to simplify. For example, your current directory is under cat. Okay? Then this current directory, to represent the current directory, you need to specify the full path. Full path means always start from the root, like the spell, the mail, printer first, then this one. So sometimes, if you have this multi-level, it will be hard to specify the current directory. Instead, current means dot. So for example, cd dot change directory to current. You don't move anything. But for example, cd dot slash the a dot b dot txt file means under cat there is the a the directory, then you can find the b dot txt. You don't have to specify all the full path. So this is the special, the directory symbol. And the double dot means going up, indicate the cat. Okay, then we'd better know the difference between the tree and the graph structure. What's the main difference?
The root. The tree has a root.
Root, and also, which means
The graph doesn't have a
graph doesn't have. First, what is the common thing between the tree and the graph? Both of them have node and edge, right? So node and edge. So see the node and edge and the node and edge. So this is the idea, the common thing of the graph and tree. However, tree has direction. Okay? Direction of what? Parent to child. Always parent to child. So there might be parent of parent of parent, and finally you can have the node that doesn't have the parent, that is a root. On the other hand, there is a node that does not have the child. Any child, that is the leaf node or terminal node, any. So there are different types of node in the tree. Root, leaf, and the internal node. So these are the node. And also, always the direction from the parent to child. One parent and multiple children node. So this is a tree structure. So using tree structure, we can manage a number of directories. Okay? Like how can we access? This is a generalization of this one, two-level directory. Okay. However, this one still has a, for example, let's see the list or any, yes, this list. There is a list file, list directory under the P on the program, and there is a list all the way over here. So suppose that they are the same file, but if they have the different patterns, so we cannot have the share the same file under the tree structure, because you can that is one of the problem of the tree structure. Once you go to here, you cannot access the other sibling node, so you cannot share. So tree structure can reasonably serve the generalize the problem of the naming and grouping, but it's not very flexible. So to address that one, so I don't have to explain how to access this one, you already know. Okay? But to address this one, so we can define the acyclic graph. So graph is different from the tree. It doesn't have the root. Why? Because we can consider the graph structure, each node has a thing. For example, here, even this one can share the count. They are the children from the different, the parent node. So you can share. However, here we do not allow this directory point to the one of the parents, because in that case it will cause the circular pointing. So which means it's a cyclic, no circular the point, the graph structure. Yes.
By parent directory, does that also include ancestor directory? Like parent to parent to parent, like it's not allowed to do that?
Yeah, so we do not allow for example, if we allow this one to point to, for example, word. So this will be the word, parent of word can be W7. So this is not allowed here, the acyclic, the graph. So it's more generalized, the directory structure. Okay. However, it allow share the file. Okay, it share the subdirectory or the file. So for example, list can be shared by the W and the word here, and also this file can be shared by the different directory. So this is implemented in your current file system. For example, how can you implement this one in your Windows file system, like NTFS? It's a shortcut. Using the shortcut, if you allow the shortcut, this is the file. And what about the the Unix system?
Symbolic link?
It's the link, symbolic link. Which means if you create the file here, b.txt under AA. So I have the bb directory, but I direct the pointer. This one you can create the link. It's the ln command. ln command, source, destination. So source is the b.txt. Then you can create the a.txt. This is the shortcut. Physically, how many files? How many data? It's one. But it can be shared by the other. So using the link or the shortcut, you can implement a cyclic graph. Okay? Then there are two types of link if you are using the link command.
Hard link and soft link.
There is a hard link, there is a soft link. Soft link is this one, shortcut. So if you create the file, then create the link, only physically one file. But from the two pointer you can access. However, on the other hand, hard link, if you link this one, actually it creates the a.txt file using hard link. Then they are actually, even though there exists two files, they are synchronized, like connected. So if you change the data a.txt, it will be automatically applied to b.txt. If you change the b.txt, automatically the change. It's a hard link. Windows does not provide a hard link, but Unix system, Linux system has such a hard link. So using the link and shortcut, you can implement a cyclic graph to share the data or file or the subdirectory. If you allow a cyclic graph, enter this one. So this is the general graph directory structure. This is what you are using most of current, the modern file system. They allow such the general graph directory structure. Like if you see the ABI is the pointer book. And the parent of ABI is the book, but the parent of book is also ABI, the directory. This is a general directory structure. Problem. It's mostly the convenient, so you can share, you can solve the naming rule and the grouping problem. But the problem? What if you delete the file over here from the count? I mean the count currently here, then delete this file. What about the count in this directory? So still directory is what? It's a FCB header information, not real file. It's a deleted, but still FCB manner information is existing. It's called a dangling pointer. Dangling pointer means it only has the header information, not real data. So we need to resolve such a dangling problem. How can you? It's not a difficult problem. There are several approaches. For example, you can backtrack of the pointer. Mostly directory has the pointer, but even file has the parent, the directory information. Where is my FCB? Where is my metadata? For in this case, two of them. In case it's deleted, you can backtrack and delete or something. You can still exist whether you can do something. So backtracking or sometimes daisy chain solution. Daisy is like you have the daisy is usually like this way. You have stem, then there is a flower like this. So to manage the file, I think that this one is from the electrical engineering to design the circuit, the daisy chain design, something like that. I'm not sure because I'm not very good at the design. I heard that. So when we manage the file, so we have the something pointer, list of the pointer, and have the file information separately. So whenever deleted, we can keep track of that. So that is a dangling pointer problem. Or we can have the garbage collection. If there is search all the directory FCB and check the file whether there exists or not. If you cannot find, then remove such information. That is the garbage collection. Yes.
For the general graph directory,
Yes.
It can go cycle.
Yes.
Can
Like
the
this one.
directory also point to a file in like an upload directory?
Oh yes. So file cannot pointer the directory, okay? Because a file is not a directory. So directory can point the directory. You can link the two directory, like create a shortcut for your folder, okay? But the file cannot. But file can be shared by the link or the shortcut. Okay? So that the other mostly popular one is you can keep from time to time periodically check the whether it's a dangling pointer or it's the garbage collection. Where did you hear the garbage collection? Garbage collector. I heard that in Seattle, one of the garbage collector, his yearly salary is 300,000.
We're in the wrong industry.
I mean, they have a lot of the overtime, the work. So total, the yearly salary is 300. Even though I think the New York Manhattan, you can easily get 100,000 if you are doing garbage collector driver. But where did you